Advances in our understanding of oncogenic cellular pathways have uncovered new targets for therapeutic intervention. One such emerging target is the peroxisome proliferator activated receptor family, abbreviated as PPAR. PPARs are transcription factors belonging to the ligand-activated nuclear hormone receptor superfamily. They are versatile receptors that contribute to adipogenesis, lipid and glucose metabolism, immune function, cell growth, and cell differentiation. PPAR pathways are implicated in numerous diseases, including obesity, diabetes, cardiovascular disease, and cancer. Synthetic PPAR gamma agonists, or thiazolidinediones, with well-delineated safety profiles have already been developed in diabetes patients and are in clinical use. The tissue expression and cellular and systemic function of each isotype is relatively specific. Current cancer research is focused on the PPAR gamma isotype. PPAR gamma is a key factor in various cellular functions, including adipose tissue differentiation and survival. PPAR gamma is also expressed in multiple tumor types, including lung, breast, colon, prostate, and bladder cancer. PPAR gamma is activated by several naturally occurring ligands, including long-chain polyunsaturated fatty acids found in fish oils, eicosanoids, lipoxygenase products of linoleic acid, and compounds from medicinal plants. It can also be activated by synthetic ligands. Activated PPAR gamma binds as a heterodimer with retinoic acid X receptor alpha, triggering multiple pathways. These pathways may prevent or inhibit tumor growth and metastasis. In this pathway, the activated PPAR gamma RXR complex downregulates cyclin E and upregulates cyclin kinase inhibitor P21, inducing cell cycle arrest and decreased cell proliferation. Epithelial mesenchymal transition, which contributes to tumor progression and metastasis, may also be suppressed via pathways triggered by PPAR gamma activation and RXR binding. Modulation of PPAR gamma is an interesting target for oncologic therapy with the potential to inhibit tumor growth and metastasis through multiple pathways. Future research into the mechanisms and pathways triggered by activated PPAR gamma may reveal new and promising anti-cancer